This is an introduction to the energy model. Before we study the energy model, we've got to look at the different forms of energy. The first form of energy that we'll look at is kinetic energy. Kinetic energy can be thought of as the energy of motion. For an object to have kinetic energy, it must have mass and must have velocity. So therefore, it must be moving. And the next form of energy that we'll look at is gravitational potential energy. Gravitational potential energy is the energy stored in a system of masses as a result of the relative positions to each other. So we can look at the gravitational potential energy of a particular object by knowing its mass, the acceleration due to gravity, 9.8 meters per second squared. Notice we're not using a negative sign there. We'll talk about that later. And the relative height. So this would be the gravitational potential energy of an object near the Earth's surface. The next form of energy that we'll look at is elastic potential energy. Elastic potential energy is the energy stored in a spring. In order for a system that includes a spring to have elastic potential energy, we need to know the spring's spring constant, and we also need to know how much the spring is either being compressed or extended. Finally, we'll look at work. The units for all these types of energy and for work is the joule, after James Prescott Joule. And we'll also be talking about how energy is the ability to change the environment. It's a really vague description, and you're going to see why that is later on. Now, let's look at some examples. Again, for an object to have kinetic energy, it has to have mass, obviously, and has to be moving. In this particular example, we're asked to find the kinetic energy of a 2 kilogram car when it is moving at 3.0 meters per second. 2 kilogram car must mean it's a really small toy car. So if we plug this into our equation, our kinetic energy would be equal to 1/2 times the 2.0 kilograms of the car times its velocity, which is 3.0 meters per second, and we're going to square that. So we end up with a value of 9.0 joules. So this object has a kinetic energy of 9.0 joules. Gravitational potential energy, again, is the energy stored in a system of masses as a result of the relative positions to each other. In our case, our system normally includes the Earth. So if we've got one object, we're going to compare its gravitational potential energy to the Earth's. Or in other words, we will use the Earth as part of that system. Now, this particular question says, what is the gravitational potential energy of the 2 kilogram car when it is 1 meter above ground level? Now, this is the equation that's written on your equation sheet, but I really like to think of this equation as written like this. The gravitational potential energy is equal to the mass times acceleration due to gravity times h minus h initial. Now, h initial is completely arbitrary, where we decide to put our h initial. Okay, so that's completely arbitrary. Now, for the most part, we choose h initial to be at ground level, but really it can be anywhere. So if we assume that this is at ground level, h initial is at ground level, then our 2 kilogram car, which would then be here, would be obviously 1 meter above ground level, just like the problem says. So we would take m, which is the mass, 2 kilograms, multiply it times 9.8 meters per second squared. The height of 1 meter minus the arbitrary point we chose to make h initial, 0 meters, and we would get an answer of 19.6 joules. So this car here would have a gravitational potential energy of 19.6 joules relative to this point. Now, we could say the same thing if we arbitrarily choose this 1 meter mark. Let me choose a different colored pen here. I will choose this color. So if we decide to make this level right here, this 1 meter mark, if we decide to call that our reference point, if you will, then 1 meter above that, which would be right here, would mean that I would have a gravitational potential energy of 19.6 joules relative to this position right here. So again, we can decide to make this H initial, we can decide to put that anywhere we want. That's completely arbitrary. Now, the final example that we'll look at is elastic potential energy. This question says, how much elastic potential energy is stored in this system when a 2 kilogram car is pushed 0.03 meters into the spring that has a spring constant of 100 newtons per meter? So we're taking this car and we're pushing it in a distance of 0.03 meters. So to find its to find its elastic potential energy, we would simply put that into our equation. The spring constant is 100 newtons per meter. One way of thinking about this is the higher this number, the stiffer the spring. And multiplying that times how far we're compressing it, 0.03 meters, and squaring that would give us a value of 0.045 joules. So these are the 3 different type forms, if you will, of kinetic energy, of energy that we will be studying. Kinetic energy, gravitational potential energy, and elastic potential energy.